In continuation of the previous class, let us have more discussion on reflection of light on the plane mirror. The reflection of light on the plane mirror produces the image which is known as virtual image or apparent image. The virtual image means the image which we cannot project on the screen. It always lies behind the mirror, the virtual image. So let us recall the reflection of light on the plane surface or the plane mirror. The mirror is one side is transparent, other side is opaque, like this. It results in reflection of light on the plane surface. These lines indicates it is normal to the point perpendicular to the plane surface, and these two lines are incident ray and reflected ray. If the incident ray makes an angle with the normal, any angle, and will be reflected like this, so that I equals R. If the incident ray lies along the normal, if the incident ray is along the normal, that is I equals 0, not making any angle with normal, then R is also equals 0. It means the reflected ray is in the same line but in the opposite direction. See that if the incident ray is along this line, reflected ray is along the same line but in the opposite direction. Incident ray, reflected ray. If this is the case, incident ray and reflected ray with some angle. This is about the reflection of light on the plane mirror. So let us have a more discussion on the image formation by the plane mirror. Let us consider the plane mirror like this, and let me take an object, a point object on one side of the mirror. Here, point object. If the light falls on the object, it will be reflected in all the directions. The light will be reflected from the surface of the point in all directions. And the light rays which are, that is, passing in this direction towards the plane mirror like this. If you keep the plane mirror nearby this, these reflected rays from the surface of the object are in all directions like this, in all point here where we are in all directions. If this is the ray reaching the plane is further reflected like this on the plane of surface. And if the incident ray is along the normal, just like this. Incident ray reflected is on the same line. Above this line, the incident ray reflected like this. At every point, we have the same kind of reflection. Or below the line, similar kind of reflections at every point like this. I am taking only 2 points here. So every point the same similar reflection. These are reflected rays. These are reflected rays. And this is a reflected ray along the normal. And when this reflected ray is extended in the backward direction like this, all these lines meet at one point like this, extension and intercept at the point, one point. This point is where the image is the point of image formation. This object, not this point, is the image formation. It is always behind the mirror, inside the mirror. So with these reflections, when you look at this object, when you look at this, look from this object, this image is observed. This is virtual image. It is not a real image, virtual image, because this is a real ray, this is an apparent ray. It appears as if the rays are diverging from this point. Rays are diverging from this point. Divergent. These are divergent rays, backward extension. So it appears as if the rays are diverging from the source of this point, from the object, that is image. So that is the reason this is observable when you see from this. It is called image, virtual image, the point image. And interestingly, it is at the same distance. The distance between the object and mirror, distance between the image and the mirror, both are same. At the same distance, image is appearing behind the mirror. And one more about this point, about this. If any object or mirror is making a movement with certain velocity, then the velocity of the image also changes accordingly. Suppose if the object is moving with a velocity v, it can move closer to this or towards this or away from the mirror. If it is moves closer to mirror, the image also moves closer to the image. If this is moving away, this also moves away. If the object is moving with a velocity v, the image also moving with the same velocity. Any movement of object, there is a movement of image. The same velocity. Object and the image are the same velocity. Suppose the object is fixed and the mirror is moving. If the mirror is moving with a velocity v, then observe that the velocity of the image is double, 2v. Fixing object, moving mirror with velocity c, the image velocity is double. That is what v moves with 2v. That is regarding the relative motion among these three objects: image, mirror and object. Relative motion. If object moves with velocity c, image with the same velocity. If the mirror moves with velocity v, image moves with 2v velocity. This is about the point object. Let us take the object of certain size and shape. That is the size and shape. And look at the image formation on this plane mirror. So to draw the image, what is that? Every point you have to take. I am taking this point, the top point of the object is like this, shape and size. Let us consider the point where the lights are what is that reflected from this point towards the mirror. So only the point, I am taking the light coming from this point. This light, if we in this direction reflected, and in this direction is reflected like this. And reflections are multiple, numerous now. If you take the same point here, every point the same kind of reflection from this point. And these are reflected rays, and the light coming from this point. And when you look at the divergent lines, that is extending this in the backward direction, all these are, that is, merge at this point, intercept at this point. Any lines like this intercept at this point indicates that this point of object is visible at this point. Same distance, same size. Like that, every point is visible. If you take this point, correspondingly this point visible here. Like this. If you take this point and these lines are lights are not showing reflected ray, the incident and reflected rays are not shown for this point. So like this, every point, when you visualize this, every point correspondingly you have this point like this, like this. So just for reference, I am taking one point. It is visible like this, and the entire thing is visible because of reflections and corresponding divergence like this. So this is the image formation at the same distance and the same size of image formation, same size, same shape of image formation at same distance it is behind the mirror. There is a virtual image because again every point looks like the light was diverging from the source of light like this. Every point like that are shown. It is a virtual image, and the image is erect. What is the meaning of erect? Upright. It is not upside down. It is upright. And interestingly, the image is inverted laterally. What is lateral inversion? It is not vertical inversion, lateral inversion. Lateral means left side looks right, right side looks left. Only lateral inversion takes place. And the size remains same because the magnification of plane mirror is always 1. The size of image divided by the size of the object is always 1, same size. The magnification is 1. Therefore, we have the same size. Same size, same shape, only lateral inversion takes place. The mirror image. Mirror image is laterally inverted, everything remains same. That is what the object of certain size and shape. One plane mirror gives one image. One plane mirror gives one image like a social image. If there are two plane mirrors, let us take in different alignment. These plane mirrors are in parallel and these plane mirrors are in perpendicular, and these plane mirrors make an angle theta between them. If we take any two plane mirrors like this, what about the images? The images produces number of images, not one images, many images they produce. So now let us take the mirrors in two parallel alignment. That is, the angle between them is 180 degree. When they lie in parallel like this, and keep the object at the center of the mirror like this, and view from this point, we see an infinite number of images on this side, and also if you look at this side on this mirror, there are infinite number of images on this side, infinite number of images. There are parallel mirrors like this. What is the reason for that? The reason is apply the law of reflection. From this point, if the incident ray on the normal, here normal, incident ray, reflected ray on this side. I am talking about the object reflecting on this plane mirror. When the incident, I am taking the ray in this direction, reflected like this. After this reflection, you see that there is one more mirror is there, because of in parallel alignment it undergoes further reflection like this. Got that? Reflection from this mirror, and this reflected ray is further reflected from the second mirror like this. And again, because of the same now, one more reflection like this. See that the reflections becomes infinite number in between the planes in this direction. Similarly, if the ray I am taking from here in this direction undergoes the same process, a reflection, one more reflection, and one more reflection, one more reflection, repeated infinite number of times. Again, this side reflection, incidence ray and reflected ray on the normal. When you look at this reflection and reflected ray and extended in the backward direction, this image, this object on this image produces, on this mirror produces this image. If the distance between this object and the mirror is 1 centimeter, it also is 1 centimeter from here. So this image due to object on this mirror. Enough. Similarly, we have on this side, this object will appear as image on this side, on the mirror like this. Reflected and extended image formation. I1 is the image formation on this mirror by the object. I2 is the image formation on this mirror by the same object, this side. 1 centimeter, 1 centimeter. Now, look at this image. This image reflected like this on this continuation is further reflected. So this reflected ray as if appears from this, as if it appears from this object, that is virtual image. So it appears from this and reflected like this, and we extend like this image formation by this image now act as an object on this mirror. It is not a real object, it is a virtual object. Object is only one. With this image formation, this image now behaves like an object on this mirror. This is a virtual object, not a real object. Virtual object on this mirror. As a result of this reflection and extending back, that is divergent ray on this line, produces the image I4. This image is the image formation by this image. So this image produces one more image on this plane. Similarly, we have this image act as a virtual object on this mirror. So this is the virtual object. Here the divergent ray like this backward and reflected and form a image like this. This ray produces image like this. Virtual object. This image produces this image on this mirror. Similarly, we have this image. This image produces this image on this mirror. It is a virtual object. Similarly, we have this image produces this image on this mirror. So like this, infinite number of reflections, this side and this side, produces infinite number of images on either side. So that is why it is not one reflection but infinite number of reflections. So if the distance between this is 1 centimeter either side, if we say that this is 1 centimeter, this is 1 centimeter. whatever the distance from this point to this point, this mirror to this image, look at this. This behaves like a object on this mirror. The distance between this object and the mirror is 3 centimeter. 1 centimeter, 1 centimeter, 3 centimeter. So it's produce the image at a distance of 3 centimeter. Similarly, this produces image of 3 centimeter, distance of 3 centimeter from this. So this image produces the image is a distance of 3 centimeter. This should be at a distance of 3 centimeter on the other side. Mirror, object, image. From here to here 3 centimeter. From here to here 3 centimeter. So like this, when you do calculations, it is 1 centimeter from the image and the mirror, and from the image and this mirror is 3 centimeter. And the image and the mirror is 5 centimeter, like this. 1 centimeter, 3 centimeter, 5 centimeter. Similarly, we have one more way, 7 centimeter, 7 centimeter, 9 centimeter, 9 centimeter. If at the center of 1 centimeter either side. The infinite number of images produces. If the mirrors are in parallel alignment like this, infinite number of images we get. If the mirror are in perpendicular direction like this, 90 degree, if the object is at this point, how many images we expect from these two mirrors? And from this object produces the image due to this mirror. This object produces the image due to this mirror, similar like this. Reflection, reflection, incident, reflection along the normal and this extended and diverge at this point. This one image by this object due to this mirror. Similarly, we have this image due to this mirror by this object. Normal, here incident, reflection, normal line, along the normal. This is divergent, backward image formation at this point. This distance and this distance remains same. So we get two images due to the reflection on the space, the light emitting from this point, this side and this side. If the light reflected on this portion nearby the corner, that is at the corner of this, like this. This reflected not like this. That is, example, a reflection and one more reflection due to the plane mirror nearby. So like this, look at this. If the light is from this, what is that? Light ray is from this on the plane surface, reflected at this point, and it is reflected in this direction like this. So there is one more plane mirror is there, undergoes one more reflection in this direction. Okay, the reflection not simply only like this, it is a reflection, further reflection and bounce back. Because in this portion, the sides are nearby, the planes are nearby. If you take the ray in this direction on this plane, it is reflected and further reflected. Look at the direction of ray, reflected and it is further reflected the point and reflected back like this. Now look at this reflected ray due to this. It is two reflections, second reflection and second reflection. The reflected ray extend this point, they intercept at this point. And reflection along, what is that? That is incident and reflection along the normal like this. All intercept at this point. So there is one more, what is at this point? possibility of one more image formation due to these reflections, double reflections here, in only single reflection. So due to this alignment, how many images are possible? Three images. Here three images are possible if the plane mirrors are like perpendicular to each other. This is if the plane mirrors are, and in general the angle is theta between them, any other angle, because one complete rotation is 360 degree. If it is 180 degree, this is the possibilities. If this is 90 degree, this is a possibility of number of images. Let us say in general, theta is any angle between the two mirrors, and this line is a bisector of the mirror, exactly bisecting the two mirrors. What would be the number of images formation by this system? The number of images forming by this mirror depends on the angle between the two mirrors. Theta depends on the theta as well as the position of the object in between the mirrors. The number of images produces some number of images. Those number of images depends on the angle theta and the position of the object which lies in between the mirrors. We have some formations. We have made some formulation on the basis of number of images forming in this system. This is the formulations. M is a numerical value we get when you divide 360 by theta. What is 360? For one complete rotation 360 degree by this theta, angle between these two mirror, if you divide 360 by theta, we get a numerical value. The numerical value, it is either even number or odd number or fraction. There are only three possibilities. Numerical value. It may be even number, odd number, or fraction. If it is even number and the object, the position of the object is anywhere in between the mirror, maybe here, or here, or here, or here, anywhere between the two mirrors, the number of images formed are m minus 1. One less than the m value, number of images. If it is even number. If the m is odd number, the numerical number is odd number, that is 3, 5, 7 like this. And there are two possibilities in this case. If the m is odd number and the object is anywhere between these two mirrors, if the object is anywhere between these two mirrors, the number of images same as the value of m, n equals m. M stands for the numerical value you get by dividing this by this. It is same as m. N stands for number of images. And one more possibility about this number, if the image is on the bisector, what is bisector? Only on the line, maybe here or here or here, the object is on the bisector, the images are m minus 1 less than the m. And last one, if the value of m is fraction and the object may be anywhere in between them, anywhere in the point, the images is n equals m, same number of images we get. So these formulations are made on the basis of experimental observations, taking two mirrors and varying angles like this. And we have worked out some examples. Here, if the angle between the two mirrors is 60 degree, 360 by 60, m value is 6, we get even number, 6 is even number. If the angle between them is 60 degree and the object may be anywhere in the space, the number of images formed is 5. 6 minus 1, 5. 5 is the number of images when the angle between them is 60. If the angle between them is 120 degree, that is 360 by 120, 3 odd number we get. If the angle between them is 40 degree, we get odd number. For this angle 120 degree and anywhere for 120 degree, anywhere is that the object is anywhere in the space, the number of images remains same, that is n equals 3. M equals 3, n equals 3. And for 40 degree, you can calculate like this. Here 9 image. 9 is a value, odd number. If it is on the bisector, if the angle is 40 degree and the object is on the bisector, it is m minus 1, that is 1 less than 9, 8 number of images you get. If the angle between the mirror is 40 degree and the object is along the bisector, the number of images is 8, is the number of images by these two mirrors. And the last one, if the angle between them is 50 degree, it is going to use 7.2, m equals 7.2, a fractional value. If it is fraction and the object may be anywhere in the space between them, the images are 7. 7.2 means 7 is the number of images. The angle is 50 between them. Images are 7 images we can see by these two mirrors. So these are the calculations involved for CET and objective questions. So this is about the image formation by the plane mirror. One plane mirror produces one image and two mirrors with different alignment produces number of images, and this one produces infinite number of images. It is about the image formation with the plane mirror. It is all due to reflection of light from the plane surface. With this, we have completed this portion. Thank you.